Good day everyone, I am Jocelyn Ubas Papa and I will talk about science's method and results. True to this definition, science aims for measurable results through testing and analysis, a process known as the scientific method. Science is based on fact, not opinion or preferences. The process of science is designed to challenge ideas through research. One important aspect of the scientific process is that it focuses only on the natural world according to the University of California, Berkeley. Anything that is considered supernatural or beyond physical reality does not fit into the definition of science. When conducting research, scientists use the scientific method to collect measurable, empirical evidence in an experiment related to a hypothesis, often in the form of an if-then statement that is designed to support or contradict a scientific theory. For the most part, science reputation stems from the objectivity brought upon by an arbitrary, rigid methodology whose very character absolves it from any accusation of prejudice. Such infamy effectively raised science on a pedestal untouchable by other institutions. Its sole claim to reason and empiricism, garnering supporters who want to defend it and its ways. In school, the scientific method is introduced in the earlier part of discussions. Even though the number of steps varies, it presents a general idea of how to do science. Let's proceed to the 6 steps of scientific method. First is to observe, determine the problem, formulate hypothesis, conduct experiment, gather and analyze, and lastly, formulate conclusion. First, make an observation or observations. For example, the toaster will not toast. You will observe and determine if there are unexplained occurrences unfolding. Second will be determine the problem. You will formulate some of questions like why? What exactly is the issue? Why isn't the toaster working? Why won't my toaster toast? You will determine the problem and identify factors that involve. Third is to formulate hypothesis. You may think that in this problem, maybe the outlet is broken. Through past knowledge of similar instance, formulate hypothesis that could explain the said phenomenon. Ideally, the goal is to reject the null hypothesis and accept the alternative hypothesis for the study to count as significant. Can also be separated into additional steps such as to generate prediction or to infer from the past experiments. Fourth is conducting experiment. You may come up with the idea of, if I plug the toaster into a different outlet, then it will toast the bread. Conduct experiment by setting up dependent and independent variables and trying to see how independent ones affect dependent ones. Fifth is gather and analyze. Even after plugging the toaster into a different outlet, it will not work. The bread is still refusing to toast. The hypothesis is not supported in this case. As a result, you'll come up with a new idea. Maybe there is a broken wire in the toaster. Gather and analyze results throughout and upon culmination of the experiment. Examine if the data gathered are significant enough to conclude results. Lastly is to formulate conclusion. Then you'll try to fix the wire, and it will finally work. The bread is finally toast. The hypothesis is supported in this way. But what exactly is the issue with that particular outlet? Formulate conclusion and provide recommendation in case others would want to broaden the study. At least in the students' formative years, the above routine is basic methodology when introducing them to experimentation and empiricism. Two distinct features that give science edge over other schools of thought. Throughout the course of history, however, there exists heavy objections in the scientific procedure. The lines separating science and the so-called pseudoscience becomes more muddled. This is the scientific method of the toaster. In observation, the toaster will not toast. Next is determine the problem. Why won't my toaster toast? Third is formulate hypothesis. Maybe the outlet is broken. Next is conducting experiment. If I plug the toaster into a different outlet, then it will toast the bread. Fifth is analysis. Even after plugging the toaster into a different outlet, it will not work. The bread still refusing to toast. Lastly is the conclusion. Then you'll try to fix the wire and it will finally work. The bread is finally toast. Jamie Tanner, a professor of biology at Magpuro College, told Live Science. She quoted, "As a field biologist, my favorite part of the scientific method is being in the field collecting the data. But what really makes it fun is knowing that you are trying to answer an interesting question. So the first step in identifying questions and generating possible answers or hypotheses is also very important and is a creative process. Then once you collect the data, you analyze it to see if your hypothesis is supported or not." Let me show to you the other example of scientific method.
And then we'll switch the laundry, unload the dishwasher, and then I'll plant you guys.
Oh good, you're back, Robo. Who are you with?
No one,
Who are you talking to?
just these sweet plants.
I didn't know you had a soft spot for plants.
I don't. I just want them to grow healthy and strong. And I read on the internet that talking to them helps.
You've got to be kidding me.
What?
Robo, you can't believe everything you read.
I don't. But I believe this.
Absolutely not. It's impossible.
It is not.
Fine. Prove it.
All right. I'll talk to these 24 plants and see how high they grow.
But then how can you tell if talking to the plants helps them grow taller? You need to randomly split them into two groups. Talk to one, but not the other.
Deal.
Excellent. Let's write this down so we have a record of it. Tell me your hypothesis and I'll write it down.
My hypothesis is that talking to plants makes them grow higher than plants that are not spoken to.
Great. We'll measure the plant growth every other day for 2 weeks.
And other than hearing my amazing voice, the plants will receive the same treatment.
Great. So same amount of water, same amount of sunlight. Let the games begin.
But the mums I bought last year didn't live that long. I'm sorry, I shouldn't be telling you this. I don't mean to scare you. I just wanted something that would last a little longer. So I thought bean sprouts were the way to go. You guys were also on sale, so that helped the decision somewhat.
How's the plant talking going, Robo?
Great. It's time to measure them. Okay, should we compare each one's height individually, or...
No, I think we should take the average.
Good idea, Reem.
Okay, the plants that were spoken to have an average height of 4.12 centimeters.
Shoot. The plants that I talked to have an average height of 4.13 centimeters.
That seems pretty close to me.
Let's plot these points and keep measuring. I guess I was wrong.
Don't worry, Robo. You're not wrong. It's just that the data doesn't support your hypothesis.
What do you mean?
Check it out. See here? How you made your hypothesis?
Yeah?
At the end of an experiment, the data either supports your hypothesis or does not support your hypothesis. In this case, the data did not support the hypothesis, but it doesn't mean you're wrong.
So, you're saying I'm right?
No, I'm saying that you would have to do more tests. The data from this test did not support your hypothesis, but this is really just a first test. If you really believe your hypothesis is correct, I would do another test with a much larger sample size.
More plants?
Many, many, many more plants. The more plants you use, the more accurate your results will be. Then, you can do real statistical analysis on them to see if there's an actual difference. A statistical difference.
Which would be more complicated.
Right. You would want to prove that any difference in the plant groups is greater than the amount usually seen by scientists when comparing two random sets of plants.
I knew you believed in me, Reem.
Oh, don't get me wrong. I think the theory is baloney.
Well, I'll start my big test tomorrow. And get ready for some chatter in the lab, because I have a lot of plants to talk to.
Go for it. Just don't think it'll help them grow faster.
Here are some key underpinnings to the scientific method. The hypothesis must be testable and falsifiable. A According to North Carolina State University, falsifiable means that there must be a possible negative answer to the hypothesis. Research must involve deductive reasoning and inductive reasoning. Deductive reasoning is the process of using through premises to reach a logical through conclusion, while inductive reasoning uses observations to infer an explanation for those observations. An experiment should include a dependent variable which does not change and an independent variable which does change, according to the University of California, Santa Barbara. An experiment should include an experimental group and a control group. The control group is what the experimental group is compared against, according to Britannica. The scientific method attempts to minimize the influence of bias or prejudice in the experimenter. Even the best-intentioned scientists can't escape bias. It results from personal beliefs as well as cultural beliefs, which means any human filters information based on his or her own experience. Unfortunately, this filtering process can cause a scientist to prefer one outcome over another. For someone trying to solve a problem around the house, succumbing to these kinds of biases is not such a big deal. But in the scientific community, where results have to be reviewed and duplicated, bias must be avoided at all costs. That's the job of the scientific method. It provides an objective, standardized approach to conducting experiments and, in doing so, improves their results. By using a standardized approach in their investigations, scientists can feel confident that they will stick to the facts and limit the influence of personal, preconceived notions. Even with such a rigorous methodology in place, some scientists still make mistakes. For example, they can mistake a hypothesis for an explanation of a phenomenon without performing experiments, or they can fail to accurately account for errors, such as measurement errors, or they can ignore data that does not support the hypothesis. The process of observing, asking questions, and seeking answers through tests and experiments is not unique to any field of science. In fact, the scientific method is applied broadly in science across many different fields. Many empirical sciences, especially the social sciences, use mathematical tools borrowed from probability theory and statistics, together with outgrowths of this, such as decision theory, game theory, utility theory, and operations research. Philosophers of science have addressed general methodological problems such as the nature of scientific explanation and the justification of induction. The scientific method is critical to the development of scientific theories, which explains empirical, experiential laws in a scientifically rational manner. In a typical application of the scientific method, a researcher develops a hypothesis, tests it through various means, and then modifies the hypothesis on the basis of the outcome of the tests and experiments. The modified hypothesis and then retested, further modified and tested again, until it becomes consistent with observed phenomena and testing outcomes. In this way, hypotheses serve as tools by which scientists gather data. From that data and the many different scientific investigations undertaken to explore hypotheses, scientists are able to develop broad general explanations or scientific theories. Scientific method is an approach to seeking knowledge that involves forming and testing a hypothesis. This methodology is used to answer questions in a wide variety of disciplines outside of science, including business. Scientific method provides a logical, systematic way to answer questions and remove subjectivity by requiring each answer to be authenticated with objective evidence that can be reproduced. There is not one correct way to list the steps in scientific method. Regardless of how the steps are documented, the goal of scientific method is to gather data that will validate or invalidate a cause and effect relationship. Scientific method is often carried out in a linear manner, but the approach can also be cyclical because once a conclusion has been reached, it often raises more questions.